So Nick, we got a question in from Ong who asks a question that you might have some input into. He says he feels like networking technologies is just a lot there these days, so much more to know than there used to be, and there used to be a lot to know. So it's even worse. Anyway, the question is, I am trying to focus on service provider technology. So if he wants to focus on service provider technologies, what are the new things to focus on?
So service provider world, which is where I spend most of my time, there's a couple of things coming up. Like, really, you got to know your routing fundamentals, right? I would recommend that you learn ISIS as your routing protocol, because it scales larger than, say, OSPF does in a saner way, in my opinion. A lot of large carriers will use that as a protocol. It also allows you to run multiple protocols in the same routed protocol and doesn't rely on the protocol. It's routing for communication. So I would learn that. Segment routing seems to be, SR-MPLS seems to be the thing that is the up and coming.
Did you just kick SRv6 in the head?
Well, SRv6, I absolutely love the idea of it because I am a very strong v6 proponent. Mm-hmm. But as you can imagine, stuffing however many 128-bit addresses into the header is going to cause hardware problems, right?
That's going to get better though. So SRv6 Plus and the proposals there are going to, I think, compress a lot of that data. Although I can tell by the look on your face, Nick, you're going, nah.
I mean, now I got another box out there to manage that's doing all the hard work, right? I mean, the SRv6, whatever it's called, the box that the plus box that maps things.
Yep.
I really think, and for the foreseeable future, SR-MPLS is probably going to be, because I can run it now. Like, I am running it now.
Yeah.
And service provider mean time to replacement is typically 7 to 10 years. So,
do you know the interesting thing about SR-MPLS is it's basically OpenFlow just using MPLS tags. It's static routing with MPLS tags. That's literally what it is.
Yeah, I mean, it's...
source routing with MPLS tags.
Yeah, source routing with MPLS, you're pushing your label stacks down. And even that has hardware limits, right? A lot of the label stack depth on the hardware gear is going to, or on the service provider gear is going to be 12 to 18 labels. So if you've got an international network and you want to do explicit EROs, you're using binding SIDs and stuff, and then that becomes a little bit more complicated. And also...
I'll tell you where it's really going to become complicated is SD-WAN is causing sort of this collapse in MPLS where customers are putting SD-WAN onto MPLS and internet and finding that internet works better than MPLS and then switching off their MPLSs. And the prediction is that the roll-off on MPLS is going to be very rapid, all right? And at that point, telcos are going to end up sharing their MPLS backbones because there's not going to be enough customers to justify running one yourself. But if you can only run 12 MPLS tags, you can't do carrier to carrier with SR MPLS because you're going to have to, like, if you want to run, you know how most mobile phone companies don't actually own their towers, they actually share them. Mm-hmm. So in the UK, there's only 2 companies running mobile phone towers. And one of the companies is jointly owned by 3 of the telcos. And every time you connect to a tower, it could be a tower, right? And the long-term strategy for MPLS, in my mind, is going to be they're going to have these MPLS networks, but they're not going to be owned by the telcos. They're going to be owned by a third party because they just can't run them themselves. You can only justify MPLS when everybody's using it. And if you get to the point where enough customers just say, why am I sending traffic on an MPLS? I'll switch it off. Then all of a sudden the MPLS services collapse because there's not enough scale. There's not enough volume to have them.
Well, I've never been a huge proponent of private MPLS overlays just because you can. Like in the early days when I was doing service provider work in the 90s, basically it was IPsec, it was poor man's SD-WAN, right? Yeah. And I have had many arguments with many people that I think SD-WAN is just lipstick on a pig, right? It's all the same protocols underneath with a fancy GUI on the top that makes it easy to use. And that's cool. And that's got very, very clear use cases. But the fact that people are turning down these, these MPLS services that are like dedicated VPLS overlays,
the private WAN stuff,
unsurprising to me. Like I smelled that coming along before the SD-WAN phase.
Well, that version of SD-WAN is already obsolete by and large, and we're talking about. Maybe we'll talk about it today. Maybe we'll talk about it some other time. But to my mind, the first generation of SD-WAN was this dynamic path switching over IPsec tunnels, right? Or SSL VPN, just depending on your vendor. And that's already obsolete. And the next generation is where they're putting security services over the top of that. So if you're going to have a router at the edge of the network and it's an x86 box running Linux, why don't you just run a whole bunch of VMs that, or services like firewall and threat detection, malware scanning, content inspection, content logging, user authentication. And that's already here. The companies that are doing that are already here in SD-WAN. So all of a sudden the router is like, that's a telco technology. Forget that. What we want is an x86 box at the edge that does all these other things. And that's the emerging play in SD-WAN. And path dynamics, this automatic failover becomes like table stakes. It's already table stakes.
Yeah, no, I don't disagree with that. I love that. I love that model. I do think that there is definitely a market for SR MPLS or any SR technology for that matter in the market of the telco space, regardless of who owns the footprint, in allowing for NFV services, right? So if I say, well, I've got this whatever, I've got a 1 gig circuit to my data center or 10 gig circuit or whatever, and I want DDoS protection, DDoS scrubbing over it, very trivial to use SR MPLS to push the label stack through a scrubbing system, right? So, yeah. And the overlay stuff is typically not managed by SR MPLS, like the big VPLS overlays. That's a different thing. And I definitely think that so
what you're saying there is that if you've got an MPLS enabled backbone, you can give people EO MPLS or VPLS service, Ethernet MPLS services over here. You can give people IP MPLS services, and that's got value. My point is that if people just move to the internet, then that all becomes largely redundant, right? If you can sync.
I don't agree with that, because I think that the internet is going to be abstracted away on top of these carrier networks that are doing traffic engineering via label switch paths, right? They're not going to buy that service, that overlay service anymore. But if I've got, 2 paths and I want to maximize both of them, this is kind of the open flow thing again, right? Where I want to run all my WAN circuits as hot as I can, right?
Well, that works if I'm doing business with just one telco. But I can't trust one telco to do things right. So when I'm in an SD-WAN environment, I have multiple telcos, right? So mainly because the telcos suck so bad, right? So if that's the case, then I don't want my telcos traffic engineering. I just want them to build as much bandwidth as possible, which then runs them further into the ground because they have no value to it. You as an operator might think you could tune your bandwidth by do traffic engineering. My point is that traffic engineering is a complete waste of time because nobody cares. Everybody just wants to put their traffic on the internet. Stop traffic engineering. Just let me get on with it.
I think you're talking about it from the enterprise perspective, and you're right. Like, nobody cares. They just want a fast pipe. They don't typically care about the amount of hops or anything like that. But the folks that are running the backbone providers, whether they consolidate or not, they care about where the traffic is hot and where it's not. And that's where they will use the tools that I'm talking about to steer the traffic around, which will be totally transparent to the end user and give them exactly what you're asking for.
That makes sense. Hey, Ned, quickly getting back to the viewer's question about areas to be interested in for service providers. Have you been looking at any of the service provider projects coming out of the Linux Foundation, like OPNFV, ONAP, that kind of thing? Is that someplace to know?
No, I haven't looked at any of that. Where I think there's a poverty of great people is folks that understand automation at scale. And, network to code folks are really helping to change that, turn that around. But at the service provider level, that's something that they're much slower. And so having the ability to understand automation platforms and how to do that at scale across large geographic areas where it's a truck roll if you mess it up, that's important. There's definitely a lack of folks that understand optical substrates. So, DWDM platforms are becoming much more prevalent, not only for inter data center connectivity, but also, as more and more fiber goes into the ground, something's got to light that up. And, that's a very specific skill set that there's not a lot of. It's hard to get too. That's the other thing.
Well, there's a few things going on there. One is, if you're building an MPLS network, the biggest problem you've got now is you can't make IP routers big enough. Like terabit class IP routers are still emerging. that do MPLS. Although you can do it in Broadcom ASICs at 12.6 terabits per second, most people actually aren't using that. They're still building using those legacy chassis routers that the big vendors have got, you know, the PTX and the Cisco CRS and that sort of stuff. And really, those people would be better off just using a white box because they get more performance for less money. But it would cause them to re-architect their network substantially. So not a trivial exercise, right? But what I am seeing is, for example, a lot of routers now have optical line cards in them. So instead of the days of the router had all Ethernet or all ATM or all fiber channel, nowadays you actually get these line cards which are optical, and then you just run them straight into a DWDM switch. And a lot of those DWDM switches are a lot easier than they used to be. Like once upon a time, those things were fairly arcane, right?
I mean, they're still fairly arcane. They're just not nearly as horrible as they, you know, it's not a Windows Java app that you need to run it anymore. But you're right. So the packet optical is the term that I've always used to, you know, so you're putting colored optics in a DWDM blade in a, you know, in like an Juniper MX or a Cisco, what have you. I think there's going to be more and more of that as the mean time to replacement goes on, because as things like open line systems become more popular, which basically an open line system is, you know, you have a shelf that's your optical shelf that controls the transponders, and the transponders may or may not be from that particular vendor. Historically, it's, you know, the old model of if I buy vendor X, I have to buy optics from vendor X. DWDM platforms very much the same way, except for 100 times more.
Yeah, so, most of the magic's in the RODM or the transponder.
And
RODM/transponder.
It's in the transponders and the RODMs, and as open line systems become more and more deployable and obtainable, I think that having that optical knowledge is going to be more and more important, because you're gonna end up saving on transponders, and you're going to end up having a converged, you know, optical routing platform that, so if you've got the skills to understand the layer 3, the layer 2, and then the layer 1 as well, then, you know, that's a pretty big toolbox to draw out of when you're looking for jobs.
So if people are listening, there's an most excellent presentation called Everything You Ever Wanted to Know About Optical Networking But Were Afraid to Ask by Steenbergen. I'm trying to think of his first name. Richard Steenbergen. And he presents it at NANOG every 3 or 4 years, I think. And it is, I'll be honest, that's where all of my optical networking comes from. And that's not quite true. That's a slight exaggeration. But if you read that, I've put a link in the YouTube chat, and we'll put it into the show notes at some point. But it is a truly wondrous introduction to the physical. About 50% of optical networking is understanding physical, like how laser light propagates down a glass tube, and how the wavelengths work and the overlaps. It's a bit like Wi-Fi. If you want to understand optical networking or Wi-Fi networking, you have to understand 50% of the physical before you understand any of the logical. So it's a fantastic presentation, and the deck is there, and he also has a YouTube on NANOG. Go to the video on NANOG, which is on the YouTube, and you can watch it, and you'll just have so much, you'll just learn so much in a short period of time. It's brilliant. I really highly recommend it.
That's an excellent resource. And if I could add one thing to that, the one thing I learned, I don't really touch the optical gear much anymore, but when I used to do it, the one thing that I learned was more important than anything else in that space. 2 things. 1, never turn on the Raman amp with nothing plugged into it, because it burns up immediately and you have to get a new one, and it's probably about $100,000. And two, learn how to use a cleatop to clean and a proper scope to scope your fiber, because 9 out of 10 times the reason it's not working is because it's freaking dirty.
Yeah. Physical. 7 out of 10 network failures are physical cabling faults, and especially in the optical network, it usually is.
Absolutely.
It's pretty interesting.
Micro bend. You see a fiber that's bent just too far, you can actually watch the OSNR change.
Yeah. I think we'll see a lot more optical networking, simply because if you've got, like they're talking about now, 400 gigabit per second optical transmitters, and if you've got 400 gig signals on a single wire, that's an awful lot of traffic that you have to route in a router. Okay. So the real thing is to you can't route IP packets at that sort of scale. Like if you're at petabit scale, you can't route IP packets. So it makes more sense to replace the IP core with an optical core. Okay, so that you're actually just routing the packets at the edge, but trunking them over an optical core at high speed. And that's the likely future. Instead of this, the last 20 years of migrating to IP everywhere is probably finished. And we're going much more towards an optical core with an IP edge. And they'll be routing at the edge, but optical switching in the core.
I can tell you for sure that that's the future. I have no doubt, because we're basically doing that now. It's we call it hollow core.
Okay.
Yeah,
that's pretty painfully obvious to anybody who's watching the industry. So I sort of started talking about that 3 or 4 years ago. I was fairly sure that, IP routing doesn't scale. It just can't. You can't bring a packet in, read it, recalculate the CRC, and then send it back out on the wire. That's just, at 400 gigabit per second or 1.2 terabits per second, that just doesn't make sense with the current silicon that we have today. The silicon tomorrow will be different, but hey,
Tomorrow's tomorrow.
Hollow core sounds like an emo metal subgenre.
It probably is.
It really does.
Go on Bandcamp and search for it.
Yeah, I want the trademark if it isn't yet.
So Nick, you could finish your thoughts up on the changing world of the service provider for Ong with one follow-up question here. He says he's gonna keep digging into MPLS and go into segment routing as well. But what about layer 3 VPN services? Do those go obsolete because SD-WAN is coming?
I don't know. I mean, I think that the ones that are there, so L3 VPN to me is that's boutique net stuff, right? You got to have a very specific reason to do that. But I do think that as the service provider worlds evolve, the overlays like the L3 VPNs are not going to necessarily go away. What I think you're going to see go away is the VPLS overlays in favor of fast,
today
raw internet access.
Yeah, today carriers offer Ethernet services. And that means you can do DCI over them. So you can extend your data center to data center. And if you want to route over them, it's up to you to be smart enough to route over the top of them, which is what you should be doing. But the telcos chose to give you Ethernet so they could sell more stuff to idiots, right? Because there's plenty of idiots, and that's what, that's literally how they said it to me, by the way. I've actually spoken. They go like, yeah, it'd be stupid to do Ethernet, but there's plenty of stupid customers, so we've got to have stupid products to sell to stupid people, right? So the point is that if you give Ethernet, you can route IP over it, and that's up to you to be smart enough to route IP and not use Ethernet and get the looping, the bridging loops that you have. And increasingly, people will stop buying that as SD-WAN replaces the need to, and cloud too. So we're starting to see things like data center interconnect technologies over layer 3. So vMotion can be done over L3. And with the arrival of NSX for overlays in the data center, we don't need Ethernet for DCI because NSX has an overlay. So when you vMotion a VM from here to here, the underlay doesn't have to keep the network coherent, the overlay does. And that changes the nature of the process. So over time, if the DCI market will fade out slowly, which is what will happen, and keep in mind that if a market doesn't grow, it's dying. As far as business is concerned in the current either. Even if DCI stopped where it was and stopped growing and just stayed with the same amount of revenue, that's not enough for telcos. They have to grow or die. And so if it's not growing, then that technology gets phased out for something that grows, and L3 VPN is growing. That's what people want. And it's also substantially cheaper for vendors to put L3 VPN in than VPLS. VPLS consumes a lot more resources in the backbone, if I'm right.
Yeah, I agree that I think that the VPLS stuff is sort of sunsetting right now in the from the business perspective, right? Because like you've said, they just want fast internet and they're going to run whatever the overlay technology is over that, and the overlay stuff is becoming so easy to use now. It's literally just I put a box in and I push a button and it's done. And so like where I think the L3 VPN things will remain is within the service providers themselves for carving out route tables and things like that. I don't think they'll continue to offer that as a service, at least maybe in the next 10 years or so. That'll phase away. So because that's X amount of route tables they have to manage, right?